So today I'm going to talk about our DTN transport layer security implementation and evaluation in operational environments. So as you know, terrestrial internet is characterized by continuous end-to-end connectivity, very brief round-trip time, and the data links are symmetric, whereas in space networks are challenging because of the disrupted networks without end-to-end connectivity, even near Earth space, because of the constant orbital movements, and the extreme distances involved cause long round-trip times that could reach up to 44 minutes in the case of Mars, negating ACK-based protocols like TCP/IP, and we have it's also characterized by high rates of data loss and asymmetric links. And as you know, the scale of space networks is increased significantly in recent years due to the number of satellites launched recently, and expected to continue to increase with more than 100 lunar missions expected in the next decade. So it's key to secure these assets and have an interoperable space network. DTN is NASA's solution to the communication in this, as you know, in the space environments, providing automated and reliable communication using the bundle protocol security. Using the bundle protocol, which is an approach for space network transport that forms a store and forward overlay network. Included in this suite of communication protocols is the bundle protocol security, which is which provides a delay tolerant transport layer security needed in this type of networks. So this slide explains the main security challenges for these space networks. Link disruptions, when they partition the networks, it prevents nodes existing in different partitions from synchronizing their information, and prevents the functioning of security algorithms that rely on state sync through the network. In addition, each node needs to make storage, routing, and security decisions not only based on their current topology, but on the presumed future topology of the network, which causes challenges for the establishment of security tunnels, key management and selection, and security policy enforcements. And DTN's security protocol needs to provide security at rest, which is needed because of the store and forward characteristic of DTN. HTTN, or high rate delay tolerant networking, is the performance optimized implementation of DTN by NASA Glenn Research Center that can provide high rates and the order of multi-gigabits per second, and it's targeting applications involving high rate RF and optical links to help increase the amount of science data returned on future space missions. Recently, on November last year, HTTN was launched along the Illumity payload to the ISS on an NHP ZBook laptop. And Illumity was paired with the LCRD, existing LCRD, to form a bidirectional link, laser link for the first time at 1.2 gigabits per second rates. So the delay transport, this slide explains the delay transport layer security mechanism that we have. So the protocol proposed by NASA as a standardized approach for space network transport is the bundle protocol version 7. And the protocol data unit of BPV7 is called, is the bundle. and it consists of a primary block and a payload block with one or multiple extension blocks in between. This is needed because we cannot guarantee the state synchronizations between the endpoints, and the bundles need to carry the information needed for their forwarding and delivery. So, and in this slide, you could see the format of the bundle protocol data units of BPv7. So the traditional way of encryption the traditional protocol, security protocols, encapsulate part of all the information of the protocol data units. This is not possible. So for DTN, we have security BPSec or bundle protocol security that targets individual blocks within the bundle. So as you can see here, we have an abstraction security block. The abstraction security block structure consists where, so it shows the basically this it's a common abstract security block structure which consists of the target security context, security source, security parameters, and security context results. This slide, now I'm going to talk about our HTTN architecture for BPSec. So HTTN architecture is modular. The core modules consist of ingress, router, storage, and egress, which can be either part of different processes when HTTN is distributed, or part of the same HTTN1 process, like in this example. BPSec is was added as a separate library, which depends on BP codec. It has the feature that it can encrypt, decrypt, and modify the bundle memory in place. I don't know why it keeps moving. Yeah. So so BPSec library was added as a separate model. It depends on BP codec, and it applies the policy the policy rules. As soon as I touch it, it moves. No. Yeah. So I think I will come. So BPSec was added as a separate library. It's has a dependency on BP codec, and it applies. It interacts with BP applications like BP send, BP receive, and ingress modules by applying the APIs, security APIs, so that are needed. So the BPSec library has two main models: the BPSec bundle processor, which has the this is the main class, the first class BPSec bundle processor, which has the methods for adding and processing BCB confidentiality and BIB integrity blocks based on security policy rules, and it implements the cryptographic functions using the OpenSSL APIs, using the OpenSSL FIPS module. And the second class is BP codec library, which adds and removes security extension blocks. And it uses the bundle view 7 class as a helper class for reading, parsing, validating all blocks within the bundle protocol version 7, which makes it easy to add and remove bundles as needed, extension blocks as needed. And BPSec policy, BPSec, the second class is BPSec Policy Manager, which has the methods for adding, looking up BPSec policies based on bundle fields and processing mapping of the security event failures to actions. This shows our BPSec config tool, which allows to, has a user-friendly interface, and we can match based on the parameters like the bundle source, security source, or bundle destination, so to add more configurability and fine-tuning. So, for example, in this case, if we want to add security for all bundles going to a certain destination or coming from a certain source. And these generate JSON config files on the backend. So in this case, this is the config BPSec JSON part, the policy rules. So for a source node, any bundle coming from sorry, yeah, the key. I think I needed the mouse. It's not easy to, yeah. So, for example, for a source node, any bundle coming from a certain source, we're going to apply a given integrity rule on a target payload, security context. So we need to add a BIB or BCB. So here we have our BPSec config security operation events that can be, we specify how we're going to process the bundle in case of security failure. And it also generates this in the config, JSON config file. We have the our regression testing based on RFC 9173, which is fully part of our unit test suite, and it was instrumental in developing the library. We thank Ed Berain for the thorough RFC. It was very helpful for our testing. And we did some integrated testing, either using integrity only by adding BIB. So in this case, for example, the bundle source provides an integrity signature of the plain text associated with the payload, and an integrity signature is applied to the canonical form of the payload block and is added in the BIB, in a BIB extension block. Then the acceptor node does the verification and processes the security operation. If the processing fails, the target shall be processed based on the policy rule for handling security failure specified in the BPSec config file. And here the same, the bundle source encrypts the plain text associated with the payload. A BCB extension block is added based on the security context parameters. The acceptor node does the security verification and decryption of the payload. And if the processing fails, the target shall be processed based on the policy rule in the JSON config file. So in case we also tested both integrity and confidentiality, where we add both BCB and BIB blocks. This next slides show some integration testing we did in our lab to prepare for the infusion of HTTN on the ISS using multiple nodes simulating geosynchronous orbit, where HTTN is the gateway. So the blue link shows the laser, is the RF link, and the orange is the path for the optical link. And we use the entropy to emulate the long delays. With this testing, so we show here the results while with and without BPSec, sending files from OGS1 to and OGS1 without BPSec and OGS2 with BPSec. So that we see the data rates are similar with and without BPSec, in this case with confidentiality enabled. And the next scenario is the lunar scenario. So we used multiple nodes simulating cislunar scenario as shown in this network topology. And depending on the orbital mechanics, we have here a rover. It may have a line of sight to a single or multiple nodes. And the entropy was used to emulate the long delay between the Earth and Moon links. And the results shows that without BPSec, so the first, the rover is the first pictures show the rover sending 1 GB files and the MOC receiving the files with BPSec disabled, and the second shows the same result with BPSec enabled with integrity, and we could see that the data rates are close in the case with and without BPSec. Then next, this slide was shown earlier by Rachel. It's basically as part of our LCRD Illumati demonstrations, we had the opportunity to test BPSec and evaluate its performance in the field environment using laser links. We were able to communicate with the ISS from a PC-12 aircraft operating out of NASA Glenn Research Center using HTTN. So we sent fun pictures like pet pictures from NASA employees and useful data such as instrument data bidirectionally between the ISS and the aircraft and the ISS and the NASA Center and Glenn. So the network connects the aircraft to the ground station in Ohio, then to the optical ground stations to LCRD and Illumati. Here I have a video of showing the setup on the plane. So yeah, here we could see the GUI, the HTTN GUI, showing the yeah. So we have an operator on the plane. I was on the plane in this case. Daniel Rabel. And then we have our, on the back, we have our onboard camera that we use to do live streaming to the ISS. Okay, slide. So the results with this flight test is that we were able to securely, successfusly do secure bidirectional file transfer to and from the ISS to a plane without mission control center involvement. Using BPSec with BPv7 with BPSec, confidentiality and integrity were both demonstrated. So we could see here the picture of the ground nodes, and then we have the plane, and this is, we had a flight over Lake Erie, so this is the itinerary. And this one shows the store and forward part. So when there was turbulence, or clouds, in this case, we had a turbulence So we could see the data, the storage link, and then as soon as the turbulence ends, we could see the software recovering quickly. So this is like showing in operations the store and forwards DTN capability. And then we also we had additional flight testing with using the grounds at GRC hangar, where we tested electrocardiogram, EKG sensor testing, where we sent encrypted passenger, our colleague Prash. We had his biometric data sent from the plane to the ground with both BPSec confidentiality and integrity. And we could see here, so the part about the logs access decryption successfully, and you could see the BPM. So he did some push-ups on the plane to increase the heart rate and test the. And then we had also, we were able to test the, so actually we were communicating with the ground originally using ION BP chat. That was what we used for the ISS testing. And we had two interns develop an HTTN BP chat, so that we tested last week, and with BPSec. So, and we were able also to do the live streaming from with sound and audio from the plane to the GRC ground. This was tested after the ISS experiments. And I put here a video when we first had the sound from the plane to the ground. So, yeah, so so this is the live streaming from the plane using DTN.
50 minutes and for the next several hours. We're probably going to be done with this mission in about an hour, and then look for an ILS tactically today. Okay, thanks. Hey, Brazil? It's dark. They couldn't hear us and asked. Oh. All right. They heard my smooth radio voice. That's a good one to give away. Bravo Kilo, turn right heading on 085, the airport on 0. They say quality of sound is almost perfect. Wow. All right. That's just going to Adam. Great.
Okay. So the next one is with. Okay. How do we? So the next one is with BPSec.
Can you talk then testing the audio? You want me to say? Yeah, why not? If I was a rich man, that's what.
Okay. Yeah. Okay. So with this implementation, we verified confidentiality and integrity services work as expected, and that we can still achieve high rates in the order of multi-gigabits per second with BPSec enabled. And that security, so despite the long delays and disruptions, did not much degrade the performance. Yeah, and that's all I have.
First time I've heard that DTN experimentation included physical exercise.
Yeah.
Other questions? Yes?
Yeah, what's the highest effective data rate achieved You just link ULCRD to like
980 megabits per second.
megabits per second?
Yes.
Okay, so almost a full 1,000 base T from the link T.
Yeah, the limitation was that 4 viewing everything.
Oh, I know. Trust me, I know.
Yeah, the OC. Big questions to someone?
It's just when you show like the graph on like of the architecture, I'm just wondering because I see that the BPSec is tapping into the application as well. So I'm just
Yes,
wondering,
so-
do you change application or not? A switch.
Okay, so our HTTN applications are using the BP source pattern and BP sync pattern, which already have the same options. So they're inheriting all the applications that we have. I'll go back to that one.
You just need to change the configuration file, enable it.
Yes, it's an option that's already there as part of the class. So, and because we want to have end-to-end security, so that's why.
What was your resource utilization delta or penalty? I think it's not. You said.
Resource utilization. So we tried, one of the things is the encryption in place to reuse, like limit the copy and the memory. So we have that optimization using the BP codec library. So that's why this library dependent on BP codec, which provides, I think here I can mention. So I don't think we measured I don't know, Brian, if you did in your testing any of that.
I don't know. Yeah. CPU graphs.
I don't think so. We just tested the data rates compared in our automated test suite. Yeah. Sure.
I do know. Ironically, encryption is faster than integrity because of the OpenSSL utilizes the AES structure instead of the processor. It doesn't have the SHA structure on the processor. So encryption's actually pretty quick. AES is so.
Yeah, other questions? Oh, okay. It's your lunch break. So
This graphical interface to configure the security policy rules, is that open source or?
Yes. It's actually will be integrated with our GUI. That's the plan, but right now it's separate. Yeah.
when it was Brian.
Yeah. Is there any visibility in the security from the application side or any influence on security from the application side on the individual bundles? Or is it blanket policy?
You mean the policy rules?
Yeah, meaning is there a way for an application to indicate this ADU needs encryption, or is it blanket policy?
I guess I could try to answer that quickly. So right now, unfortunately, our apps are one thing that HTTN itself is working on is an actual app registration. So right now, our apps are standalone nodes. They have their own node number. So you can choose to apply BPSec there at the app, or you could apply it when it's at the HTTN is done.
But it's for the entire flow, not for ADU, right?
Flow, what kind of like
It's an endpoint, like it's tied to the endpoint. Like, this ADU should encrypt this ADU.
Oh, okay, right, yeah, it's based on security source.
Although that's that it isn't just the source of text. If it's IPN, for example,
you could also be applying security as a function of service to that node ID. So you could always break out different securities for different services to that node ID.
Alberto, you have a question?
Deciding on OpenSSL versus something else.
OpenSSL.
Did you analyze other
No,
ref functions or just that?
just we've been using OpenSSL only. Yeah.
Okay. So then let's thank our speaker again.